Hello everyone. Today we'll talk about gradient descent. There are n number of videos on YouTube to describe gradient descent and its usage in linear regression, for example. In this one, I'd like to approach it using an alternative way. We'll have a function f of x is equal to x squared plus 3 such that x is greater than or equal to 0, and our objective is to find the minimum of this function, right? And we'll use gradient descent to arrive at the solution. Okay, so let's start. First, we'll try to solve this using the graphical method. And by graphical method, I mean that we'll plot a graph and we'll visually figure out, because this is a simple function, what can be the minimum of this function. So let's try to plot x squared plus 3. Now x squared can be plotted as a function like this. Now if you'd want to draw x squared plus 3, we would shift this towards the right hand side, and our plot will be something like this. Okay, so now looking at the plot, our minimum is going to be here, because this is the curve. Our minimum is going to be here, which is 3, which also makes sense. If we substitute the value for x is equal to 3, then f of 0 is equal to 0 squared plus 3 is equal to 3. We can also try to solve it using the differentiable method. Say f of x is equal to x squared plus 3. If we find the derivative of f of x, it's going to be 2x. Now, if the derivative of a function is 0, then that will become the minimum, because there is no appreciable change between the data points. So if we set LHS as 0, we'll have x is equal to 0. So we have arrived at the same solution using two methods. Now we'll use gradient descent to arrive at the same solution. Gradient descent has an update rule, and that is the only rule that we'll follow. So the update rule in gradient descent is x will be updated as, this is the symbol for updation, will be updated as x minus alpha, which is the learning rate, into the derivative of x, right? So if we plug in the values, say x will be updated as x minus alpha. The derivative of x is what we have figured out earlier. It's 2x, right? And say we would want the learning rate to be 0.1 for now. Then x will be updated as x minus 0.1 times 2 into x, which is equal to x minus 0.2 x, which is equal to 0.8 x, right? So the update rule will state that in each iteration, x will be updated to 0.8 times itself. So say for iteration 1, the value of x, which is the old value, and then we'll have the new value of x, right, at the end of iteration 1. And on the side, we'll also plot. So this is our x, this is our y-axis. And now if we assume that, say, x is going to be 10, this is just an initial guess. The way that gradient descent works is we have an initial guess. So say our initial guess for value x is going to be 10, right? Now according to the update rule, the new x for that iteration will be 0.8 times itself. So 10 into 0.8 is going to be 8, right? And this is the value of x at the end of iteration 1. So say for iteration 1, the value was 10. For at the end of iteration 1, the value has become 8. So we have moved down a tiny bit here. Now similarly for iteration 2, we'll have the old value of 8 and our new value will be updated to 0. Well, it's going to be 8 into 0.8. It's going to be 6.4. So earlier we had a value of 8. Now we'll have a value of 6.4. So we are slowly moving down this line. Right. Now similarly for the third one, we'll have 6.4, and if we update it, it's going to be 5.112. Similarly for the fourth one, it's going to be 4.096. For the fifth one, it's going to be 3.27. Similarly, if we follow this on the right hand side, our values are slowly going down incrementally. Right? Now theoretically, if we run this for n iterations, we will arrive at the minimum value, which is 0. Right? And then the update rule will stop, because our update rule states will be updated to 0.8 times itself, and this is going to be 0.8 into 0, which is going to be 0. So this is our gradient descent. Alright, catch you all in the next one.